basically like our storage unit full of computers. Something about this we have to. The name is Magic Graphics Card. Like for different graphics cards.
Oh no.
Like literally, they work like certain DI. Yeah, like if I put it in plus one, it doesn't work. Put it in plus two, it's fine. It's still like balance and all that. Like I have like a little graph. I was like, okay, so this card is like 2 or 4. Oh, sorry. Doing everything the hard way.
I know how to.
We were writing database applications.
They want to reach things like that happen. Or we would, like our developers would write some crazy thing from scratch. They would be like, oh, that already got that. Right.
$5
So are you doing?
Somebody else already has this problem.
Just the whole thing.
Now everybody has the yellow line.
Good.
Can everybody on the phone hear this okay? Are you going to be behind there most of the time?
Yeah, I'll be at the keyboard quite a bit. So. Guess so. All right.
Okay, so did everybody pick up their evaluation sheet? We've got some books from some vendors to raffle off later today. So, again, this is Dan Dugan. He's going to be talking about Service Broker Apply. He's an IT professional with over 30 years of database administration and development experience, specializing in SQL Server since 4.2.1. which was introduced on the Windows platform. He's active in the SQL community. He's been a member, he's an officer of our user group, and he's been a Microsoft MVP since 2001, which I don't know, when did they start SQL MVPs? I think they're...
It was in the 90s. I don't know exactly when, to tell you the truth, but seems like it's been a long time. But then again, it seems like just yesterday, too. So that's what happens when you get a little older. You know?
So has
Days run together.
in here worked with SQL prior to version 4.2. I started with 6.5. That's just lucky Dan.
So nobody got version 1.0 on OS2.
Yeah.
Yeah, I miss those days like not. Anyway, I've given service broker presentations before here. Last one I call Service Broker Simplified, which I think is a little bit of a misnomer because I tried to, for lack of a better word, dumb it down. But there's a lot of moving parts to Service Broker. And so I tried to redo the presentation. So I took some of these slides from the old one, but I, beefed it up with, more demos and more concrete examples. But I don't know if I was successful or not. So I welcome any feedback you might have here. So my apologies if the flow isn't as clean as it should be here. But I did not have time to do any timings or rehearse a lot of this. So. Again, I have to apologize in advance. SQL Saturday got the best of me there, a little bit of time and effort that I did not spend on the presentation. As Julie mentioned, I've been using SQL Server since forever and have been an MVP for about almost 15 years now. So today what I'm going to be speaking to is reviewing some basic messaging concepts as applies to Service Broker. As I mentioned, Service Broker is kind of abstract in the sense that it's like there's a lot of moving parts to it, and it's kind of fuzzy because it's not really, a lot of what you guys are probably familiar with, queries, tables, the relational database engine. It's more about how to instrument messaging, transferring of data between applications, queuing, asynchronous processing. Things that I think in general DBAs aren't especially accustomed to. But it has a lot of practical applications to extend, application code, do things that you couldn't do otherwise at all in SQL. So I think that there's a lot of value in at least knowing enough about it to know if it's the right tool for a specific job or task. So I'll be actually showing some demos in both T-SQL and .NET code. Who here is actually using Service Broker, either in production or a test system? We have 3 hands, 4. Okay, that's it's both good and bad. I think that it's probably one of the more underutilized features in SQL. It's been around since, I think, version 2005. Initially, I remember before it was developed, I had the privilege of being a Redmond for one of the MVP summits when it was literally still on the drawing board. And they were, trying to figure out, and some of the discussion was around primitives like queues and, hey, should they, treat it just like it's MQ, except put it in the database engine. Microsoft has Microsoft Message Queue, MSMQ, and apparently the decision is not. They decided more to expose things in via services in a more abstract way, which is both a good and a bad thing. It's good in the sense that that abstraction layer gives a lot of flexibility at runtime and ability to move code from the database engine in T-SQL into an application service. Or the other way around, but use the database as essentially the service interface. But I'll be speaking a little bit about that in through demos. I'm going to review a lot of the DDL and the DML statements that Service Broker, that's applicable to Service Broker, and talk about some of the patterns and anti-patterns. Because there's plenty of both. Because for Service Broker, you kind of need a lot of boilerplate type code, doing things the same way to avoid problems. So as I mentioned, it is part of the SQL database engine, but it's not really relational, and that's really kind of what makes it a little bit different here. But it's more than just like Microsoft Message Queue, where you just have a queue, and you can do whatever you want to. You have somebody that writes to the queue, somebody else that reads from the queue, And generally you use queuing for, like as a way to pass data from one application to another in an asynchronous way. So one application would just write a message to the queue. Later on, maybe an hour later, maybe a millisecond later, another application can read from the queue. But that queue provides a buffer between the two applications, so you don't even care if the other side of the other application is down. You can still be writing messages to the queue, and as soon as you fire up the other side of the application, it'll start to consume messages from that queue. So Service Broker does have that same sort of concept in that the applications are loosely coupled. You don't have to have both services being up and running all the time, the writer and the reader. So it's a full messaging subsystem within the relational database engine. And it's available in all editions except for SQL Azure Database. So Eddie, when's Service Broker going to be in Azure? I figured I'd put you on the spot.
Not anytime soon.
Not soon, okay. Yeah, so generally in the cloud they have a lot of different services, and so I guess their Microsoft's direction is probably going to be leveraging the cloud-based services for brokering of messages instead of Service Broker. But for those of us in the on-prem world, Service Broker is a good, and there's some things that you can do in Service Broker that you can't really do in, I don't think, externally to the database engine, as I'll be done with in a minute here. Go to the next slide, sir. One more time. There. So SQL Server actually uses Service Broker for some of its internal features that you may or may not be aware of. Database mail. Who uses mail here? Better than half. So if you use database mail, you're using Service Broker, know it or not. And that's part of the beauty about it. I mean, you can use database mail. I mean, you're just a user of a service, the database mail service inside of the database engine. You don't know or care what's under the covers and stuff. SQL Server also uses Service Broker for event notifications, which is pretty cool, and I'll have a pretty good demo on that. And another big feature is query notifications, which allow an application to be notified anytime any data in the database changes. So, for example, you can have a web application that subscribe, or it can issue a query, and then it can just sit back and relax, and just SQL Server can notify the application that some data's changed, in the underlying tables that that query is based on, and so the application knows to re-query the database. Otherwise, it would have to continuously pull, hey, is it different? Is it different? Keep refreshing its data, cache. So I'll also show a demo on that. So the nice thing about Service Broker is that it's reliable. Everything is transactional in terms of the queues that are used to pass data to and from, the various services. It's asynchronous, meaning that the reader, or the writer, or the sender, I should say, doesn't have to wait for the messages to be processed. Just like earlier I said, the other end of the service could be down, but you can keep accumulating messages to be processed later. So if one service crashes, the other, not everything crashes at the same time. The system's still available. It's really loosely coupled to the point you can actually write a Service Broker service using any language that can access SQL, plus T-SQL as well. So for example, even though you might be using a Service Broker service, you as a consumer don't even need to know what's actually processing your messages. It could be .NET, PowerShell, Java, pick your poison. Which again adds that abstraction that makes it very, flexible. And also Service Broker is, again, with that abstraction layer, allows, applications to be very distributed. So you can actually have services that reside on different databases on the same server, even on different instances SQL. So it could be across the country, you don't know or care really as a consumer of the service. But it gives you a lot of flexibility for distributed processing. By the way, I'm not going to really speak to distributed processing today. It's fairly advanced, and I honestly don't have any firsthand experience with it myself. I pretty much stick with a single database and process that way. But a lot of the common applications for usage of Service Broker, asynchronous triggers, which is this is actually a fairly common one, I think. Because triggers, as you probably know, they execute, typically as part of the statement that fires them. So, for example, if I insert into a table that trigger that fires, it's actually part of the same transaction that's inside of the, the fired insert statement. So that means that until that statement commits, then you're holding up locks on the table, et cetera. So, by having a long-running process that runs outside of that trigger code, you can greatly speed up the processing of that insert statement, for example. Or as, another example would be that Julie shared with me at Signal Saturday is they have a login trigger, and that allowed them to do processing separately from that login trigger. That I'll speak to it a bit. And that also uses the event notification feature, too. You can do asynchronous and parallel execution of stored procedures, meaning that you can have, let's say you have an instance of a stored procedure where it gets parameters from a queue for every, execution of it. Service Broker can automatically fire additional instances of that stored procedure for you, so that if, for example, if you feed, a service with a bunch of requests to do some processing, let's say some long-running batch processes, SQL Server can automatically fire or spin up additional instances of that stored procedure and run the processing in parallel. For example, I've used that kind of a feature for a process I developed recently that was part of an archive. So we had literally hundreds of tables that needed to be archived, and the user clicks a button and says, hey, go archive data that's over a year old. It would actually spin up all those processes in parallel, the queries to basically move data from the main table to the archive tables, just using T-SQL statements to help make that happen very fast. But it took a bit of development to do that, but the benefits are we didn't have to have an application service or code that runs and has to run and orchestrate all those queries. It could all be done within T-SQL. As I mentioned, you can do distributed server-side processing, using the Service Broker remoting type features to, have requests passed to different instances, and a lot of flexibility there. Let's see, what haven't I spoken to yet? So the whole abstraction, loose coupling is the whole idea behind the service. So just think of a service as an abstraction layer, where you don't know what it's, or you know what it does, but you don't know how it does it, and that's the real key there. The definition of a service includes two main things: the name of the service, which could really be anything, but also a queue that's associated with the service, and that's the queue that provides the messages that are incoming to that service. So any request that you pass to a service, you're really just putting a message onto a queue, sending a message to that service, and it takes care of it from there. In the case of a target service, and I'll make this distinction between initiator and target service, but the initiator service is the one that starts the ball rolling. The target service is the one that actually does the work, if you will. And in the case of a target service, you can also specify a contract, which is really just a list of the message types or the kinds of messages that service expects and the work that it can perform. So, for example, in the case of like a database mail service, you would likely have a send mail message where you would say, from, to, subject, message body, all that kind of stuff as part of its payload. and that send mail service would know how to, or that mail service would know how to process a sent mail message. That would be the contract that we would specify. And I'll talk a little bit more about that in a minute here. A key concept about service broker applications is this thing called a conversation. And the main thing about a conversation, it involves exactly two parties. You can't, there's no such thing in service broker really, as the last bullet suggests, as a monologue, where you just send something and forget about it. You really need to have a two-way conversation for service broker to work. So the dialogue between two services is you have one side is the initiator, which is the guy that starts the conversation, and the other one is the target, which is the guy that basically processes a request that was sent, and actually does the work. The initiator of the conversation doesn't have to wait at all for the target to do its work, because all the initiator's really done is drop a message on the queue and go on its merry way. It may eventually want to know what the result of that work was, like if it was processed successfully or not, but that happens separately, and it can happen, seconds later, days later, whenever, if you get a response that, that work was done, or it might not really care at all. However, from a design pattern perspective, it's important that, we understand that, it's a bi-directional conversation. So and there's some anti-patterns around that too that I'll mention, in a few minutes. So the DML statement, begin dialogue, is basically how the initiator service begins a conversation with the target service. And I'll be showing all the DDL and examples in a minute here. But the main idea is that you got to have an initiator and you have to have a target of that, that conversation. And when you do a begin dialogue, it returns a handle, what we call a conversation handle, which is really nothing more than a GUID. It's a globally unique identifier that identifies the, the dialogue for that side of the conversation. So anytime I want to send a message after beginning a dialogue, I use that conversation handle to send the message to the target service. So that conversation, once I start it, I do a begin dialogue and I send a message. The messages are exchanged, can be exchanged between the initiator and target service until a service ends inside of the conversation by saying end conversation. So when a service, issues an end conversation message for that conversation handle, it said, I don't want to hear about any more messages on this conversation. I basically hung up the phone. I'm not going to get any more messages. And similarly, when the initiator service gets an end conversation message, and that results in an end conversation message being sent back to the end dialogue message being sent back to the initiator service. So he gets his, end dialogue message, and he knows the guy's hung up, so what does he need to do? Hang up. So he ends up doing a end conversation too. So the normal pattern for service brokers, start a conversation with begin conversation, or begin dialogue, I should say. And then you end the conversation with end conversation. And both sides of the conversation should be properly ended. Otherwise, what happens, you get what they call conversation handle leaks, and nasty things happen. It can fill up your database. I know Keith, we've seen, I think, hundreds of thousands of conversation handles, just because of errant applications that didn't close their conversations properly. So it's important to follow a design pattern where you don't want to fire and forget. Begin a dialogue, send a message, and then close the conversation. You want to wait, if you're the initiator service and you've started the message, you want to wait until you get an end dialogue or an error message back from the target service before you end the conversation. Otherwise, you end up with a lot of leakage of conversation handles, because the service broker's infrastructure tries to keep track of all these conversations and make sure that everything's reliable, no messages get lost, and that kind of stuff. And if you don't end the conversations properly, that can cause, issues, with that. So I always caution, especially if you're new to service broker, to make sure that you end conversations properly. So normally conversations go down the happy path and everything's kosher, but every so often, you might end up with problems where, there's an error that occurs. So similarly, if you're a service broker service and you receive a error message off of the queue, you should close the conversation to indicate, hey, an error occurred. I don't want to, hear anything more about the messages there. Because the conversation's dead. It's like the line being disconnected. Is one way to look at it. So here's the way the flow of a conversation should normally work with the happy path. The initiator service, you say begin dialogue conversation, which gets a conversation handle back. It then issues a send command. The send drops the message under the queue into the covers. Keep in mind that the send doesn't specify the name of a queue. We're really just communicating to a service. So we don't even know what the name of the queue is if we're the initiator. However, when the service itself, for the incoming messages, it knows what the name of the queue is because it's basically part of its own definition for incoming messages, and it issues a receive command to receive any messages that are destined for it. In the case of the initiator service, the only thing you're going to get back is, end dialogues typically or responses from the target service, but the target service generally issues the receive command to get the request that it's supposed to do. And then, optionally it can send a message back and then, go on its merry way, as many messages that need to be conversed back and forth. Then finally, the target service, when it's done doing all of its work, it ends the conversation, and then that'll send the end dialogue message back to the back to the initiator service, and it would end its conversation. Are there any questions so far? I know it's a bit confusing to start seeing something in action and seeing some code, but I'm trying to speak to some of the stuff because it's like 6 of one, half does the other. If I show the code first, then a lot of these verbs and concepts aren't going to make much sense. But then again, if I, do this, then it's a little bit abstract until you see it in action. So, but speaking a little bit about messages, again, it's a bi-directional conversation. They're also sent when there's an error. And importantly, every message has a message type associated with it, and an optional payload, or message body that could actually be null. I mean, you might think, why would you send an empty or null message to something? Well, in some cases, the message type alone might be enough to know what needs to be done. For example, if I, like a good example actually is like an end dialogue message. All I need to know about that message is that the other guy ended the conversation. There's no payload to go along with it because the context of the message type itself is enough to know, hey, that means the other guy hung up. I just need to hang up too. Or if there's just, there's things where, it's just a notification or a progress message or something, Messages have the ability to be validated within the service broker infrastructure, according to the message type. It can be empty. In other words, this message must be empty, like a end dialogue is a good example. Well-formed XML, meaning that it's just a valid XML message from a XML syntax perspective. Or it can actually be XML that also has schema validation, meaning that it's valid against an XML, XSD, so that it has a very well-known strict structure. And the reason you want to do that typically, meaning that, either well-formed or XML with some sort of validation, is because you want to try to protect the service from getting something it doesn't expect. So, for example, if I have an XML message that has some mandatory, elements in it, and I get something unexpected, and I try to parse that XML to do something with it, it'll blow chunks if that message isn't well formed from its perspective. So it's a good idea to at least let service broker validate that it's well formed XML, if not actually schema valid as well. It's really just it's defensive programming, if you will. It helps make sure that, you don't end up with garbage. Just like you have a strongly typed, you don't make everything a varchar max in your database because, you don't have any sort of validation on your domain. And you want to make sure that everything's properly typed and everything. So when it comes to service broker queues, the messages are delivered to the services I mentioned earlier by, in the order that they're actually sent. They're actually physically internal tables within SQL Server. You don't actually see the tables themselves, but the queue exposes a fixed schema that has several columns in it, especially the message type and the message body. And the message body is a var binary max column. And because it's var binary max, you can put anything which you ever want to in there. And that's why I mentioned on the previous slide that it's a good idea to make sure that in the case of, commonly one uses XML, the service broker, and it was developed 10 years ago when XML was really hot, So typically, you put a XML in that blob, but you specify valid XML, at least, on the well-formed XML, I should say, for the message type validation, if not also a schema validation too. You can't run any DML statements against, service broker queues except for a select statement and a receive statement. And both are limited. When you say select from a queue, you see the messages that are in the queue, but it doesn't actually pop them off of the queue. They're still on the queue. Whereas when you receive a message, that's just like selecting and then deleting. So once you receive a message and you commit the receive, if you've been a transaction, it's gone forever going forward. And then the only way to write to a queue is with a send and end conversation, those DML statements. But I should mention that, you don't send to a queue again, you send to a service. And when you end the conversation, you're actually ending the conversation for the current, dialogue dialogue handle they have. You're not really, writing directly to the queue. The service broker infrastructure takes care of doing that for you. Remember that every service is associated with a queue for incoming messages, so that's a important concept there. Any questions yet, or haven't bored you too much, I hope. I'll get to the demo really shortly here. I mentioned FIFO order for queues, and that's in the order sent. Queues are really just storing the messages on their way. They're not the data themselves. I'd like to mention that. The data typically you store in tables. Queues or messages are just, queues are just for messages for data in transit. And then, as I already mentioned, the concurrent processing by multiple threads here. So when you define a queue in Service Broker, you specify, or you can optionally specify, the name of the stored procedure that automatically gets executed whenever a message, or whenever there are messages on the queue waiting to be processed. Service Broker then executes the stored procedure for you. You don't need to have a client application. I mean, literally, you could be totally off the network, nothing connected to SQL. If there's messages on the queue, SQL Server will execute that stored procedure, and basically in its own, in the background, using its own infrastructure. You can specify how long to retain messages on the queue definition, which is something that one normally does not do. Message retain, queues are really just data in transit. After a message is received, you really don't want to leave it around. It just adds overhead. It's really for, I think that feature is mainly just for troubleshoot. So for example, if you're in development and you're sending a bunch of messages and you want to see what actually got sent, et cetera, et cetera. If you specify a message retention, once a message is received, it's marked as logically deleted. It flips the status, but so if you can't receive it again, but it's still on the queue, so you can still see it with a select statement. That's really what that means. Poison messages are messages that cannot be processed for whatever reason. I mentioned earlier, that we got a bar binary max column, and you can put any garbage you want to in there. And if the service tries to read that and then barfs on it for whatever reason, because it's garbage, chances are it's going to roll back the message. And what that'll do is put the message back on the queue. Well, then what's going to happen? Well, it's going to, next time it reaches in the queue, it's going to get the same message again. And then it's going to roll back again. So you end up basically getting in an infinite loop, and that's called a poison message, one that can never be processed. So by default, service broker queues have what they call poison message handling, and by default it's on. So that if you roll back a message 5 times or more, or 5 times, it'll actually disable the queue so that no more messages can be written to that queue. Which is a good thing for, safeguarding it. Otherwise, no message can be read from the queue, too. So what happens then is that everything grinds to a halt because of that one bad message on the queue. So, so you have to be aware of trying to safeguard your services as much as possible so that you only have valid data in those messages to prevent it from either going to a loop because you've turned off poison message handling, or if you have poison message handling on, how do you address the unhappy path of somehow there's some program bug, put some garbage on the queue, and need to be able to process that guy. So event notifications, that's a feature in SQL Server that uses Service Broker. So it's really a service broker. An event notification is really nothing more than a service broker service in a queue that is the target of a notification. The SQL Server infrastructure provides the initiator service for you, and it is, as you might imagine, an event notification service. So when you set up an event notification, really what you're telling SQL Server to do is send up an initiator service that can generate and send a message to the target service that you specify whenever some events happen. Specifically, a service broker event, one example is queue disable, like I just mentioned. If, let's say you had some poison message get into your queue and it disabled the queue, well, you could set up an event notification so that any time a queue gets disabled, you could write a message to another queue, which is for your monitoring purposes. You can also set up an event notification for, I don't want to say every SQL trace event, but a whole lot of them. Literally, I would say probably about 80 or so, I would guess. I don't know. I didn't actually count them. I have a query on my coming up here that I'll show you. And any DDL trigger type event. So, as a matter of fact, in a way, it's kind of redundant with DDL triggers because, like, how many people use DDL triggers? Only one? Oh, wow, that surprises me, to tell you the truth, because they're pretty cool. Well, I work a lot on the development side where I find them really, important. Because developers tend to jack up the database a lot, by putting stuff out there they shouldn't. But you can, for example, create a DDL trigger is really just a trigger that executes in response to a DDL, like a create table. At least database level DDL triggers, creating, any database object. You can even have server level triggers, so you could launch or have triggers fire when people create logins or, for perhaps auditing type purposes. Well, in the case of event notification, even without having a trigger, you can still tell SQL Server, hey, when that event occurs in the database engine, write a message to this queue. So even without a trigger, you can just write a message to the queue and show some practical applications for that in it. And just before I go into the demo, I just want to show you some of a few of the key DMVs associated with Service Broker. One is a transmission queue, which is typically just a short-term storage for messages that are getting routed between the initiator and target service. Typically, that guy is going to be empty all the time. But if you have problems with your service, such as a disabled queue, because of poison message handling, you can get messages that back up into the transmission queue because they can't be sent to the target service. A conversation endpoint, which has, as I mentioned there, what has one row per conversation endpoint. An endpoint can be thought of as just one end of the conversation, in the context I'm using it here. So if you have a dialogue going on, you're going to have two conversation endpoints, one for the initiator and one for the target. And we also have, conversation groups, which as the name implies is kind of just a group of related messages in a conversation. I didn't say that right. A group of related messages is one way to say it, where they can each be, it's basically the most granular unit of blocking that service broker has. It always reads messages and blocks them at the conversation group level, even if you don't create your own conversation groups explicitly. To tell you the truth, conversation groups are kind of an advanced topic that I don't think is used a whole lot in the wild, but it is important to understand that when you do a receive statement, to receive all the messages from a queue, you're going to get all the messages belonging to a single conversation group. So, and I'll demo that right now here just to kind of show you what's going on. Any questions thus far? Way too quiet here. Yeah, I find that for folks that have used Service Broker, I tend to get a few more questions. This is a little bit, it's a little bit dry until you see it in action. So hopefully this will be a little bit more interesting for you here. For this demo, I'm using the newer SQL 2016 Wide World, can't even say it, Wide World Importers database, which is available if you just use the search engine of your choice. You'll find it, that didn't come up on the slide. I got to switch I got Management Studio up here and I'm talking, so let me try this. So I'm not used to presenter mode here. I have to figure out how to get my screen switched over. Back out of it. All right, there we go. So I'm just going to start by restoring the Wide World Importers database here. Let's see. Are you not seeing it on Skype? Yeah, I'm not sure what I need to do to get it to present on Skype. I'm sorry. Click share screen again. Are you seeing it now?
Yeah, it's loading.
Okay. Yeah, sorry about that. I'm kind of Skype challenged, so you may know. So. All right. So if you're not familiar with the Wide World Importers database, it's just a new sample database that Microsoft is. Darn it. Keyboard is not doing what I want to do. That Microsoft's provided for their examples. It started with pubs, and then they had Northwind, and then they had AdventureWorks, and now they're on the this guy here, I think they would have called it Worldwide Importers, but I think that name was already copyrighted or trademarked or something. So they decided to reverse it. To tell you the truth, I'm not especially familiar with it, but I know SQL Server MVP, it's been gone, just created a couple of, I don't know if I have it here or not, I thought I did. Yeah. Created an ERD of some of the key database tables, which like I said, I'm not especially familiar with them myself, but I am going to be using the stock items table for the demo today. Just thinking that one's kind of interesting, something that might be something similar would have in the real world, in a business application. So I just restored the database, and what I'd like to do is just kind of do a quick show of event notifications here. So first thing I want to do is just show you what sort of notification events are available here. Those first few, like like here I mentioned earlier, like broker queue disabled. For the event, type, that's one that typically is just and queue activation event. Those are ones that are just for part of the service broker infrastructure. But all these ones that start with DDL here, those are all events that we can use for event notifications. Any type of, basically defaults and, all sorts of, index DDL, whatever. We can actually write messages for any of those things. And also for admin stuff too, which I'll do. That's where the trace events come in. Like in the previous session, we learned that SQL trace is deprecated, but it's still pretty baked into the engine. Matter of fact, I'm trying to get an answer to the question that I asked Microsoft about, whether or not they're going to allow us to, use event notifications with essentially something besides the deprecated SQL trace events. We should be able to do that. Either that or at least allow us to specify a service broker queue as a target for an extended event. That would be another way to, to do that. But until then, we still have the event notification feature, and it's pretty cool, to tell you the truth. Like in this case here, what I'm going to do is just create an event notification to monitor a couple of events that are of interest, specifically blocking and deadlocking. I'm sure that, you got, do people here, how many of you use a third-party vendor or tool for your SQL servers that would give you alerts for like blocking and deadlocking? So I got about half a dozen or so. For those of us that are not so lucky to have big budgets, you can always build your own poor man's way to do something similar. And to do that, for event notification, we would there's the DDL to do it right there. And that's, all I do is specify, the name of the event notification. And in this case here, they're, server events that I can, monitor. I forgot to mention it on my first script here. But after I, in addition to restoring the database, I also set the block process threshold to 5 seconds, which may be a little bit low for a production system, but I set 5 here for demo purposes. So what that means is that if there's blocking going on inside the database engine for 5 seconds or longer, SQL Server is going to generate a block process report event. And that event can be, captured with an event notification. So every time that event occurs, it's going to send a message to this service, what I call target service for event notifications. And that service is in the current database. So there's a little DMV that shows me the events that are currently in there. Now, I mentioned about those DMVs for Service Broker. the endpoints one specifically. So now that I've created that event notification, the first result set there is from the MSDB database. So now that I've created that event notification, SQL Server actually has a service broker service running in MSDB to basically, track those events so that when the events get fired, it'll write a message to the queue associated with this target event service. And just scrolling to the right a little bit, it tells me what the name of that service is in the endpoint. So, that service doesn't even exist yet because I haven't created it, but it's happy that it will once I start, so it can still actually create an endpoint for it and everything in advance of that. So let me go ahead and create all that stuff here. All right, so there I just created a queue for the event notifications. I think that'll work if I still do it out of order. We'll find out real shortly. If not, I'll have to start over again. Yeah, so I just recreated that same one. I just want to see if it, yeah, good. So all right, so now I have some, basically some scripts that'll cause some blocking and deadlocking here. So to do that, I just create a table inside of a transaction, don't commit it. Then I'll go ahead and try to read from that table. I'll create another table. And now I'll go ahead and try to read from that second table I just created, still in the transaction. And of course I'll be blocked because, that schema modification lock still held, so it's just dangling out there blocking me. And now if I go and try to read from the other table, I'll be blocked just for a second, and then I'll get, or one of us, I should say, will probably get chosen, I did in this case here, chosen as the deadlock victim. So I've created some blocking and some deadlock events. And now that I've done that, I should be able to see those in this queue, hopefully. Yeah, there they are. So for those, so the event notification service went ahead and wrote those event messages to the queue, and there it is. You see the, basically the details for the block process report here. And that generated 3 of those because my blocking was going on for 15 seconds or so, so it had several of them. And then we also have the deadlock event where it tells me, what locks are held, the typical, deadlock report. So I could use that for diagnosis. So, if I, so an hour, if there was blocking that happened an hour ago, I can then, go out and, see that, hey, here was the reason for it, or the system was slow. I think it might be blocking, so I can go out here. But to actually receive the messages, now keep in mind they're just sitting out there on the queue, which is typically something you don't want to happen forever. So if I receive these messages, notice that there's 4 messages on the queue, and there's, I don't know if you can tell very easily from the screen, but they have 2 different conversation group IDs. If I receive these, I get the block process reports first because they're all part of the same conversation group. I think the event notification infrastructure just decided to do it that way. Technically, it could probably use the same conversation group, but that's who knows why Microsoft does what they do. And then similarly, I received the message and I got the the deadlock report back. And now if I look at my conversation handles again, now before I had an empty result for the conversation handles in my database. Now I have 2 of them, one for each of those 2 separate conversations going on. Basically 1 for each event. but typically you wouldn't be, like doing this stuff in Management Studio. Chances are you want to, set up your own table to hold on to those events and stuff. So, let's make sure I don't, and all right. So what I'm going to do then is have something that's more, for lack of a better word, production ready. So I'm going to create a table for storing those results so that I have some place to do it, or some place to save the data, I should say. And I'll create a stored procedure that receives messages from those queues. And this is the typical sort of pattern that you're going to find in most activated stored procedures, where the name of this project called, target service for event notifications, because this is a target service, basically, implementation of it. And I just have a while loop, an infinite one, until I break out of it, where I do a receive top one, from the event notification queue. So what I'll do is, like any top one query, one row back, I'll get the first event that's in there. But notice that there's a wait for clause that you can wrap a receive statement around. So what that does is allows this query to basically wait for, this example here, for 15 seconds. And if 15 seconds goes by without any events being generated, the stored procedure will just exit. So I do that. I do a begin tran, so I'm doing it transactionally just because I want to make sure I don't accidentally drop any messages on the floor, because if you figure, if I implicitly receive and commit and my server crashes, well, that message is gone. In this case, it might not be the end of the day. I don't get my block process report or whatever. But if you're talking about financial transactions or something that's more important to your business, then that might not be so good. So as a best practice, if the data is important to you, you should always do a receive inside of a transaction. And also, commit once you're, when everything's happy, just like you would any, transactional application. So I basically follow the pattern where I begin a tran, I receive a message, and I get out of the proc if it's, if I didn't get any message. That's what the check for the row count is. But then I check for my expected message type. So I'm expecting an event notification message type, and if I got that, I go ahead and insert it into my history table, my blocking history table. If it's not that, it might be an end dialog, which is somewhat expected. That might happen, for example, if I tear down the event notification service, just to, cleanly close my side of the conversation. And that's what I do here. I end the conversation with that same conversation handle that I read. And if I get something else back that I didn't expect, then I just end the conversation with error. And I give it some error message context. Just meaning that, hey, I don't know why you gave me what you got, but I'm out of here now. All right, so now that I have those, if I create those, that stored procedure, I can then create a queue, and I'm using these more advanced parameters to specify activation. So I tell it, okay, here's the name of the proc I want to activate whenever their message arrives on the queue. Here's how many queue readers I want, which is to say how many instances of this proc I want to run. And typically, in this case here, I don't need to scale out. I don't expect to have hundreds or thousands of blocking reports a second or deadlocked. If I do, I got bigger problems. So I'm not going to bother doing any sort of, scale out with multiple queue readers and stuff. Did I create the table yet? I don't think I did. Yes, I did. All right, so I'll just go ahead and run the blocking scripts again. This time, I would expect that rather than me having to do those manual receives from the queue and all that stuff, you know, that activated proc should do all that work for me. So all I have to do is, you know, gather the forensic data, is just select from the blocking history table that I created, because the proc will hopefully record all the methods to it. All right, so I wrote the, yes, as you can see from the timestamp, it just wrote these rows to the table. So I have a couple of, you know, blocking reports and deadlock report. You know, so I can use that table for, you know, any sort of forensic analysis, you know, later on. So with that, you know, Dem, I just want to talk a little bit about the activation and the event notifications. At SQL Saturday, Julie shared a case where she was using event notifications. I'll speak to a little bit. I thought it was kind of neat, where she has a login trigger that's used against the database, so that only certain applications and certain users coming from certain workstations during certain times of the day can access the database. So basically, she wants to lock down the connections to the database via, you know, basically business rules. You know, you don't want developers using business objects to hit the database and cause these massive queries during peak workload times. So the login trigger worked great, from what I understand. Except there's one caveat. They wanted to be able to then go beat the person on the head that was trying to log in during that time. So, you know, they wanted to basically log that to a table. Well, the problem is, like I mentioned earlier in my talk, is that triggers always execute in a transaction, and if you roll it back, if you wrote to a table to log that, guess what? That gets rolled back as well. So the solution that Kathy Kellenberger came up with was to develop a event notification for the, you know, login failed event. I believe that was one that she used, so that whenever the login failed, you know, even though the trigger had already rolled back, it still fires the login failed event. And in the event notification, they just did exactly what I just did. You know, they just took the event, took the payload out of there and logged it to a table, so that they can then go beat the developer over the head, say, hey, why are you trying to connect? We told you not to do that, yada, yada. So, you know, it does have, you know, the idea of the asynchronous triggers is really pretty cool, too. Yeah, I just wish that Microsoft would allow us to use those with extended events, too. You know, not just deprecate a SQL trace. So that's, you know. Shift F5. Trying to remember my hotkeys here. Hopefully I got it. Okay. All right, so query notifications, I spoke to it a little bit. It basically allows you to, a client to be notified whenever data changes in the underlying table. By client, I mean to say a program. Now, query notifications, to the best of my knowledge, is probably the only feature that does not have a T-SQL interface for it. I can't write a T-SQL script to subscribe to the query notification. I have to do that in a programming language. You can even do it in PowerShell. I think there's even an example that someone has written to do that. But typically, it would be done from like a web application where you would execute a query like, hey, like my example is going to be, to get a list of the stock items in the database, which probably doesn't change too frequently. It's just a, unless somebody changes the price or something, but it's something that you would typically want to cache. So and know for your customers whenever that data changes. So, you know, that's something you would typically use, you know, query notifications for. So let me just go ahead and show you how that's done. It's, hopefully this doesn't take too long to launch. Sometimes Visual Studio can really be a pig firing up, so I'm almost surprised it's so fast there. Now, there are some caveats. Matter of fact, I have to go over to Management Studio to address them. There are some caveats with query notifications. Do any of you use index views or filtered indexes? Okay. As you may know, in order to basically modify those guys, you have to have the magic 7 set options, like quoted identifiers, anti-nulls, anti-warnings, a few others I always forget, you know. But at the end of the day, your query, your session set those 7 session set items have to be set properly, as documented in the books online, in order for you to modify that data. Similarly, there's some, for like index views, for example, there's some constructs that are not allowed in your query. You can't have any left joins, you can't have any subqueries, you can't have any non-deterministic type functions. Basically, it's a laundry list, but you know, a lot of times they're not going to be blockers, especially when in the case of event notifications, which require have those same restrictions. You can only have a single query and a relatively simple one that doesn't have all the nasty, you know, joins on it to monitor for, to be able to be monitored for data changes. So I just wanted to mention that, you know, you can't use it for all queries in every situation, but for a lot of cases it could be nice. So when I was setting up this demo using the Wide World Importers database, here, I guess the stock item tables, lo and behold, they had some of those disallowed constructs for query notification. First of all, it was a temporal table, which is the new SQL 2016 table. So, oh, it's not sharing anymore? Oh, thank you. I guess every time I close my PowerPoint presentation, it, or minimize it, I should say, it, wow, did I actually close this? Says presenting. You see it now, Julie? Paused. So I thought I did the same thing I did last time. I just, you know, got out of the PowerPoint piece there. And I'm kind of out of ideas here, Julie. It's going now? Oh well. I kind of run a little late anyway, so I'll try to get going there. Huh?
I just stop sharing and then reshare.
Oh, good. I pushed the, you know.
Yeah, reshare, but I stop sharing and then.
Okay, let me try to stop sharing real quick. If that doesn't work, I'll just move on.
Stop. Stop presenting, yeah.
Oh, presenting entirely.
Yeah,
Okay.
and then re-present.
I can just do that by sharing my screen, right? Just whenever, I didn't have to reboot or anything. It's terrible. So anyway, as I mentioned, I couldn't, when I tried to use the out-of-the-box stock items out of this, table here, it wouldn't let me do query notifications because it had temporal tables, it had computed columns, it had, constructs that were not allowed for the query notification. So just for, this is something you want to do is you really have, that in a production database, but just for demo purposes, I just went ahead and I removed, those constructs. And this is the product I'm going to run, which is obviously pretty trivial, which is the one that the application uses just to get a list of all the stock items. And then the code, see, who in here is a C# person or knows enough to be dangerous with C#, which is more like me, just enough to be dangerous, not. Okay, nobody raises their hand, but it's not unlike PowerShell if you want to go down that path. I know nobody knows PowerShell either. So all I'm really doing as far as the data access is I execute a stored procedure, that proc I just created there. And before I execute the command, whoops, I look at the wrong code, sorry. Before I execute the command, I grab a SQL dependent, I create a SQL dependency object and pass it that command and tell it, hey, what to do whenever that, that data changes. In this case here, it calls this onDependency change method. So if I go ahead and run this, hopefully it'll work. It's just a dumb console application where, it has it's multi-threaded, so it's in the background, it's basically waiting, for that dependency. So now if I just execute this thing, you see the results that this is what the application's getting. But as soon as I do I'll try to get this side by side on the screen here. That way you can see what happens here when I do an update. So if I update, let's say the price on one of the stock items, I don't know if you noticed, but in the background here, you can see that it detected the fact that had changed, and then it issued the query again because it had to refresh its data that it had in cache. So that way, instead of the application, how often are stock prices going to change? Every minute, every hour, or once a day? I don't know. And you don't really want the application to keep polling and refreshing its data all the time. And that can be pretty heavy, especially if you have a lot of web servers or something, in your environment. So SQL dependency is a good way to, in my opinion, to use Service Broker to alleviate the load on your system. It's a lot better than polling, a lot more elegant. So underneath the covers, SQL dependency did all the work for me. It created a service in the database. It created a queue in the database. It created a stored procedure to tear that stuff down. So, excuse me. So for the most part, it just runs all by itself. But it's a very powerful, application feature. Yeah, I was going to do a query notification demo, but I'm not going to have time. So, and plus, it's very hard to find documentation on query notifications, which are, I should have mentioned that in .NET, query notifications are the primitive object that SQL dependency is built on top of. Most application developers use SQL dependency, but because it's a lot easier to use. But query notifications allow you to kind of get to the underlying plumbing. It's analogous to using you know, the low-level commands instead of, you know, the higher level like entity framework kind of thing. All right. I just wanted to show some of the DDL before I finish up here. This is the complete syntax for begin conversation, where there's other whistles and bells like related conversations and conversation groups, and frankly, a lot of that stuff is not really used very much in the wild that I've seen. It's pretty advanced stuff, so I wouldn't worry about it too much. But there is one important option here if you're writing your own application exchange messages. I don't know if you all see it at the very bottom, but the encryption clause, by default, messages are going to be encrypted, which is a good thing from a security perspective. But keep in mind that means you have to have a database master key and all that. So, just be advised. If you don't want to bother, if it's not sensitive data, of course, you can specifically say encryption equal off, and you won't have to mess with it. And that's just the general syntax for the, the send conversations. I did show the wait for clause, but there's also a limited where clause that you can specify on a receive statement. Specifically, you can look for only messages with a specific conversation handler or conversation group. Which might come in handy in some cases, I guess. And also, I mentioned the timeout, which is in milliseconds, how long it'll wait before it will, return an empty result set if there's no messages on the queue. I already showed that. The last clause there, you can end the conversation with cleanup, which is really a DBA task. If you end up with a situation, like I mentioned earlier, where you have some application errantly wasn't closing its conversations and kind of left things dangling, what you could do is issue an end conversation and use that with cleanup option, which causes service broker to forcibly clean up all of its infrastructure that's related to that conversation. That's something you would not use in application code, but as a DBA function, it does come in handy. It's mandatory if you have a errant application. But typically what you would do is write a script that would iterate over all of the conversation handles and the sys conversation endpoints, and just generate and then issue the the end conversation with cleanup for each one. Let's see, I already spoke to all of those. I don't remember if I really mentioned much about the contract, but it's really when you define the service, you specify the, you can optionally specify a contract, which is the list, essentially it's the list of message types. That a contract defines a list of message types that the service can receive and all. I think the rest of that I pretty much spoke to already, so. Okay, for the distributed applications, you might have a route. A route is not required, even though I see a lot of people create them anyway, because every database, a route is only needed if you need to route messages between SQL instances, over the network. If you're on the same server, every database has a built-in route called auto-created local, and that local route it takes care of that business of have database A and database B. So like my example of the query the event notifications, where the event notifications were an MSDB, and it was able to send messages essentially over into my wide world importers database because of every database has that local created route. So it knows about the other databases on the instance. And by the way, I didn't mention it, but every database on the instance has a unique service broker ID. It's a GUID, which is used for that routing. Or maybe I didn't mention it, I don't remember. I gave another service broker presentation this morning, so I might be getting that mixed up. I spoke about that. And don't fire and forget, which is to say always make sure that you end the conversation. Okay, that's not big. All right, so One blog I strongly recommend related to Service Broker is Rosano. Ramus, he participates in Stack Overflow quite a bit. He's a real smart guy. He used to work for Microsoft, and matter of fact, I think he's one of the main guys who helped design Service Broker. So he really knows his stuff. So if you see his posts or his blogs, pay attention to them. Also, in addition to that Service Broker book, there is with the SQL Server Feature Pack, I don't know if there's one for 2016 or not, but at least there used to be with 2012 and 14, a feature pack component called External Activator for Service Broker. And what it basically is nothing more than a Windows service that listens for event notification. And when it gets an event notification, it can launch a command line application, which, like, for example, I've used it to launch an SSIS package, so I could actually write and that was the days before the SSIS catalog where you can do that out of the box today. But, with SQL 2014 and beyond. But there's a lot of, there's just an endless